So what does that mean? Okay. In the past, your Algebra 2 teachers probably had you memorize this. If they didn't, I'm going to have you memorize this because it's going to make your life with exponentials and logarithmics much, much simpler. So what does that mean? Okay, log base k of p equals m means the exact same thing as what? Means the exact same thing as what? Log functions, logarithmic functions, are exponent finders. Okay? Logarithmic functions find exponents. Can't stress that enough. The quicker you have this memorized, or if you have it memorized as that, the quicker that you have that memorized, the much faster you'll become at solving logarithmic functions, solving exponential functions, bettering yourself, bettering your abilities in this class. Okay? Much, much faster the sooner that that is memorized. Okay? All right? We're going to use that a lot today. So, solving simple logarithmic equations, solving for x. Okay? Remember, logarithmics solve for exponents. Okay? So that means that I look at what my base is here, and I put this exponent on it, and that gives me my x value. I don't see a number there. When there's not a number written, what do we assume it to be in logs? 10. Okay, we assume that this is 10. So this is 10 to the negative 2 power, which becomes 1 over 100. In number 2, what's x? So what's x? 16. Oops. In number 3, what's x? That's a trickier one. What's the base here? It is not 10 in number 3. E. Base is E. Okay. So this is E to the third, which we're just going to leave that as E to the third. we could type it in our calculators, right? I think we get like 20.8 something. Borrow the big pearl here for a second. 20.08553692. We'll just leave it as EQ. Okay. Number 4, what's X? What's my base? 10. What's my exponent? Exponents of 1/2. What does that mean? Exponents of 1/2. What? Square roots. Another thing that you should have memorized by now. Exponents of 1/2 are square roots. 1/3, third roots, fourth roots, etc., etc., etc. Okay? All right. So let's put an exponential function and a logistic function on the same graph because they're inverses of one another. Okay? So if I graph y equals b to the x, and let's say b is greater than 1. Okay? Alright? So that would make it be a growth function, correct? That would make it be like that, correct? What would the domain of that function be? Domain of my blue. Domain of my blue. All real numbers. I can plug anything in there for x and get out a value. Range of my blue. Y is greater than 0. Y cannot be 0. Y can't be less than 0. Horizontal asymptote of said function. Y equals 0. Y-intercept of said function. Zero what? 0, 1. Okay. Now, to make an inverse function, okay, a function that's going to cancel out that one, that's what inverse functions do. If I apply them to both, they're going to cancel each other out. Okay? They're fire to your ice, or whatever you want to call it. Okay? Water to your campfire. Okay? Making stuff up. You're trending opposites. Okay? My x's from the 1 become the y's in my inverse. You learned that back in Algebra 2. Okay? And then my y's from the 1 become the x's in the inverse. Okay? So, if my log function is truly an inverse, what would the domain, range, vertical asymptote and x-intercept be of them? What would the domain be? No. X is greater than 0 because the domain for this one comes from the range of the other one. What's the range of my my logarithmic function? All real numbers, because it's the domain from my original. Can't have a horizontal asymptote because I inverted it. So an invert makes it a vertical asymptote. What's the vertical asymptote going to be? X equals 0. If I take my red point here and I invert my x and my y, instead of it being 0, 1, now it becomes 1, 0. Okay. Whoa, way too far to the back. Oh well, I tried. Okay? So, the graphs of our special bases. Remember, we have two special bases in logarithmics because it's what's able to be used here on the pink pearl style of calculator. Okay? We can only do two special bases, and that's base 10 and base E. Okay? On more advanced calculators, like the graphers in the back, we can do any base. Okay? And it'll figure out, it automatically does change of base for you. Okay? You'll learn change of base by the end of today. Or I shouldn't say you'll learn it. You'll refresh your change of base by the end of the day today. Okay? So, first one here is log base 10 of x, or simply just y equals log of x. Okay? So that's going to go through the point 1, 0. It's going to have a vertical asymptote. It's also going to go through the point 10, 1. Because if I put 10 in for x here, log of 10, what exponent do I have to put on 10 to get 10? Well, that's 1. So it's going to come up along this vertical asymptote, expand out to 0, or 1, 0, and then take a sharp turn to the right. The next nice point that it would go through would be 100, 2. After that, 1,000, 3. Okay? Natural log of x is log base e. It's going to go through the point 1, 0. Then it's going to make a turn, and it's going to go through the point 2.7, 1. So it's not going to make as graphic of a turn, but it still does make a pretty sharp turn. Because it's got to go through the point E, 1, which we round E to 2.7. Okay. Properties of logs. I know you've seen these before. Last class I had, they were like, oh yeah, I remember. And then we got going, and then like, piece of cake. Okay? So there are 3 properties, 4 really if you include change of base, but we're going to talk expanding and condensing of logs today. So really we're going to focus in on the 3 properties. Okay? First is called the product rule. And the product rule tells me that if I am multiplying 2 things inside of a log, I can split that log up, and I can say that this is log base b of u plus log base b of v. Quotient rule says if instead of me multiplying those 2 things, I'm dividing those 2 things, then instead of adding, I'm subtracting. Log base b of u minus log base b of v. The power property is next. The power property actually comes out of the product rule. Okay? Because if I had like u to the 3rd power, well that would be u times u times u, right? So that would be log base b of u plus log base b of u plus log base b of u. Okay? And that's 3 of them. So this, I can take this exponent and I can bring it out in front and then just multiply it by log base b of u. Change of base formula is actually on the way bottom of your sheet 2 is where you'll also see it. But this just says that because calculators are limited, or scientific calculators, I should say, are limited in their usage for finding what evaluating logs is the word that I'm looking for. Okay? So because of that, need to figure out how to change the base. So we can use a common log or we can use a natural log. Okay. But again, we'll deal with that towards the end of class. Okay? Let's expand. So there's two ways that we're going to use these three properties. We're going to expand. We're going to take one single solitary log, and we're going to make it be a bunch of logs. Or we're going to condense, and we're going to make a bunch of logs become one log. Okay? All right? So this one is an expanding. So the first thing that I'm going to do is I'm going to write log of 100. That's the first part. Plus log of x. That's the second part. Plus log of y to the fifth. That's the third part. Okay. Then I apply power properties if I can. So I can change this one to be 5 log of y. Move that exponent down in front. Log of 100. Can I write that any differently? Can I write that any differently? Exactly. What exponent do I have to put on 10 to get 100? And that's 2. Okay? So this one actually becomes just 2. Okay? So when it's all said and done, the expansion of this is 2 plus log of x plus 5 log of y. A quotient one, so this would be the natural log of x squared minus the natural log of y cubed. Apply power properties. 2 natural logs of x minus 3 natural logs of y. Okay? You try numbers 3 and 4. So this would be log of the cube root of x plus log of y squared minus log of 10z. So this one would become 1/3 log of x. This one would become 2 log of y, and then this would become log of 10 plus log of z, because it's a product. log of 10 is 1. I get that. Questions on it? The fourth one, be the natural log of the square root of x plus 4, then minus the natural log of z to the 5th, so then this would become 1/2, because that's the exponent associated with square root of the natural log of quantity x plus 4. And I'd put that in parentheses, because if I don't put it in parentheses, it means something different. Minus 5 natural logs of z. Yes, ma'am.
Why is it minus log z?
Because this subtraction sign goes into both of those. Because they're inside the set of parentheses that the subtraction sign is in control of. Okay? Condensing now. Condensing, so in expansion, we first apply product or quotient, then the other one, and then we apply power. Condensing is reversed. So we first apply power and then product or quotient. Okay? So the first thing that you would do here is you would say that this is log of x to the 1/2 power minus log of y cubed. X to the 1/2 power is the square root of x, so this is log of the square root of x divided by y cubed. I'm going to show you number 6 in a couple of different ways. First way I'm going to show you is left to right. So this would be the natural, tap the brakes. First apply the power property, which is going to be the natural log of 2 minus the natural log of x minus the natural log of y cubed. Okay? So first way here, I'm going to work left to right. So then natural log of 2 minus natural log of x would be the natural log of 2 divided by x. Correct? Minus the natural log of y cubed. The downfall with this method is then now, when I combine these two, the natural log of 2 over x over y cubed. What's wrong with that? What's wrong with that? do you not see anything wrong with it? Fraction and a fraction. We only want one fraction at most. Okay? So I've got to think to myself, self, this is really 2 over x divided by y cubed. Well, dividing is like multiplying by the reciprocal. And then I multiply across. So then this gets me to the natural log of 2 over x y cubed. Okay? That's the long way. But it works left to right. Another way, you could say that this is the natural log of 2 minus the natural log of x plus the natural log of y cubed. By factoring out a negative 1 from the last 2, you've created an addition sign, right? Which then this would become the natural log of 2 minus the natural log of xy cubed, which then goes to that one. Yet another, probably more common way of thinking it is saying, all right, I've got the natural log of 2. That's going to go on top because I know I'm subtracting something, right? And anything that's being subtracted then goes downstairs. Well, I'm subtracting the natural log of x, so the x goes downstairs. I'm subtracting the natural log of y cubed, so the y cubed has to go downstairs. Okay? 3 different methods to do the exact same problem. Biggest takeaway from that? No fractions and fractions. One fraction only. Okay? Do 7 and 8, please. Seven, I get the natural log of the fraction x to the 5th y squared, all divided by z, the square root of z. I get log of 9 times the cube root of 5x all over y to the 4th power. You tell me why the 9 is on top. Am I adding it or am I subtracting it? Adding it. So it goes on top. if there was a set of parentheses here, then it would be on the bottom, yes. Yep. But since those parentheses are not there, it goes on top. Change of base. So remember, logs are exponent finders. So I need an exponent to go on 3 to get me 8. Okay? Not the easiest, right? Okay? It's almost 2, right? Because 3 squared is 9. Okay? But it's not, so we got to find it. And it's not easy to do on here. Can't just type it in. Doesn't have that kind of technology. If I had one of those back there, be able to type it right in, boom, move on with my life. So instead, I've either got to use log of 8 divided by log of 3, or I've got to use the natural log of 8 divided by the natural log of 3. Now, if your calculator opens up a set of parentheses, which these TI-30s usually do, you have to close that set of parentheses before you hit the divide. In either case, you should get 1.89278926. Typically, we would round to 3 or 4 decimal places. We would tell you in the directions how many to round to. Okay? Log base 4 of 16, do we need the calculators for it? What is it? 2. Okay? You can confirm it on the calculator if you want. Log base 6 of 100 I get 2.5702. Okay? Make sure you watch the flip video before you come to class tomorrow.